Buddy, it's Actuary Dude over here looking at another exam question. So a pension fund makes the following investments in £1,000,000. So it looks like we start with 12.5 mil, then we add on 6.6, 7 and 8 depending on the date. And the rates of return that we get, so between half a year we get 5%, another half a year 6%, and the full year 6.5% and 3%. We get to assume the 1st of January to the 30th of June and the 1st of July to the 31st of December are precisely half-year periods. So we want us to find the linked internal rate of return over the 3 years from that time using semi-annual sub-intervals. Alright, so let's have a look at how that's done. Well, actually, so we can do that over here. So we're going to say 1 plus the linked internal rate of return, and that's going over 3 years because we're starting in 04, 05, 06, as in first until the end of 06, which is like the start of 07, so that's 3 years. And so now what we've got to do is we're really going to be having 6 different interest rate bits over here, 1 plus i's. So for the first year, well, actually not first year, for the first sub-interval, which is the first half of the year, we know that we're getting 5% return. So we can actually write that one in, 1.05. For the next half of the year, we get 6% return, so we can write that one in, 1.06. Then the other rates come in over a full year period. So to put that in semi-annuals, we'd have to do 1.065 to the power of a half. But we do that twice, and when you put them times each other, it's squaring them, which basically just makes it 1.065. And the other one, instead of doing 3% twice a year to the power of a half, you can just do it once, 1.03. 1.03. And then that's going to give us our, then we've got to put it all to the power of a third and then minus 1. So we'll find out what I, or LIRR, is equal to using Excel. Alright, so here we have it. We have 1.05 times 1.06 times 1.065 times 1.03. And that's 1 plus LIRR to the third equals that to the power of, the third, which equals that minus 1. And as a percentage, that's going to be 6.879%. Okay, so let's write that down, 6.879% per annum. Alright, good stuff. Now, what does it want us to do? It wants us to calculate the time-weighted rate of return over the 3 years. So in order to do that, for the time-weighted rate of return formula, we have to know the balance of what's in the fund just before we receive each amount. And we can do that because we're given the returns over here. So for that one, we will need to do a bit of calculation. But 12.5 mil, and we're adding 5% to that, will give us some amount just before we earn our 6.6. So let's get rid of this. Actually, we can keep that. I'll just put it in the next column, is what we're going to do. So 12.5 times 1.05 gives us 13.125. So up over here, that's 13.125. What do we get before the 7? So over here, we've got the 13.125 plus 6.6, and we get to add 6% to that. So that's going to be equal to this plus 6.6, and it's the whole thing multiplied by 6%, 1.06, which gives us 20.9085. So let's write that one down, 20.9085. Then we get to add 7 to that, and it's going to accumulate at 6.5% per annum. So it's going to be equal to that plus our 7 over there, multiplied by 1.065. And that gives us 29.7226. Okay, so 29.7226. And then last we add 8 to that, and we get to add 3% to all of that. So is equal to this amount plus 8 times 3%. Okay, so that's 38.8542. Alright, so let's write that down, 38.8542. And now we can work out a time-weighted rate of return. So in order to do that, a time-weighted rate of return, that's 1 plus I to the power of 3, and that's equal to, so first we started with 12.5, and that's turned into 13.125. We multiply by that, and we started with 13.125. We get to add 6.6, and that's going to turn in 20.9085. Then we start with 20.9085. We get to add a 7 to that, and that's going to turn into 29.7226. And lastly, we have 29.7226 plus 8 is what we get, and then we end up in the very end with 38.8542. So how do we find out what I is? Work that all out to the power of a third minus 1. So let's just see if I can fit it all in like this. And I'm going to say is equal to 13.125 divided by 12.5, and that's going to be times by 20.9085 divided by 13.125 plus 6.6, and that's going to be multiplied by 29.7226 divided by 20.9085 plus 7. And then we can close that and multiply that by 38.8542 divided by 29.7226 plus 8, which gives us finally this amount over here. Put that to the power of a third. It looks like a number we've seen before. It's equal to that minus 1, and that is the same as this when we put it to times 100. There we go, 6.879%. Okay. So here we have it, I is equal to 6.879% per annum. So something's going on over here. That's all good, and let's see what else does it want us to do. The money weighted rate of return over the 3-year period. So let's just remember what we start with. 12.5, we had 6.6, 7, and 8. Alright, so let's note that down. So for the money weighted rate of return, we have that we're going to end up, it was 38 point something, is going to be equal to, and we had 12.5 multiplied by 1 plus some interest rate I to the power of 3. And then we got 6.6, I think it was. And then we'd be multiplying that by 1 plus I, and that was over 2.5 years. Then after that, we got 7 million. That's multiplied by 1 plus I to the power of 2. And lastly, we also then got 8, and that went on for 1 more year, times 1 plus I. And now what we have to do is find out what I is equal to, and we could do that on the calculator. I know I'd muck around using 5 and 6 and 4%, but let's just use Excel to quickly see that one. So over here, I wonder if there's an easier way to do this. Do it over here and write down that we've got. So if this will be I, this whole box over here, D4, then this one can be equal to 1. So it's going to be equal to this plus 1. Okay, so it's this amount over here that we're going to use as our variable, which we can change based on, let's just pretend that this is 5%. Alright, so let me just extend this out and quickly have a look. Alright, so we started with, it's going to be 12.5 times this to the power of 3. Then we have plus, and it was 6.6 times this to the power of 2.5. Plus 7 times this to the power of 2, plus, and then it was 8 times this, well that's just to the power of 1, and that gives us this amount, 38.044, and we were trying to get to, over here, 38.8542, okay, 38.8542, so that's 5%, so we need to make it a little bit higher, let's make it 6%, 38 point, so we need 38 point, what was it, 38.8542. So we're so close. So it looks as though now we're a little bit above. We can make it smaller, so let's just go 0.059, so 5.9%. Gets pretty close. 0.58%. So it's about 5.8. It's about 5.9. Let's say, yeah, 5.9 to 6%. So like 5.99 or something like that, 5.95. Okay, so over here we have I is equal to 5.9, I don't know, something percent per annum. And so what I think I'm finding out around this is what's acceptable. And I think if you get it somewhere between 5.5 to 6%, then you're in the right range and they'll probably be pretty good with you. So Yeah, that looks to be alright. And then very lastly, there was another part to this question, and it said, what's the deal? Explain the relationship between your answers. So between part I and double I, we got this bit, they were the exact same. And why were they the same? Because we used the same sub-intervals the whole way. So in other words, for the for the time-weighted rate of return, we used the half years. Even though these half years didn't really get used, it was still the equivalent of doing it with the linked internal rate of return. Now, if there were even smaller time periods inside of here and there was a quarter one over here or something like that, they wouldn't be the same. Okay, so that's what's made them the same. But what's the deal with the third bit? The money weighted rate of return is actually less than the time weighted and the linked internal rate. So the issue with that is when the amount had more money in it, that was when it performed not as good, when we only got 3%, and we had the most amount of money in there, and that's what it's weighted towards. Whereas at the time when we did really well was the time when we had less money. And so we weighted it towards a time when we had more money, didn't do so well, so we're thinking overall we probably didn't do as well, but in fact we may have. So thanks a lot for watching, and ask any questions if you have any.